So when we look at section 8.2 and we review what are the things that you need to be able to do, the order of 1 and 2, which asymptote you find, it doesn't matter. And Ryan, I know we could just say find both asymptotes, but I want to clean it so that we know exactly what we're saying. Determine the equation of the horizontal asymptote. Remember, it's an equation. It's got to be y equals. I like what Paige said, cover up everything except the first terms and reduce. What they said was you can use the leading coefficient of the numerator, the leading coefficient of the denominator, and your asymptote will be y equals a over c. So right here, you can see a over c, y equals a over c. That works. I caution you on that because it's not going to work all the time. If you just do leading coefficients, there's more to it. It's about the variables today. And so Paige's idea, I think, is a little bit better. The second step, find the equation of the vertical asymptote. How do we do it? Just like somebody said, I can't remember who said it, we set the denominator equal to 0. Set the denominator equal to 0, and it's x equals, again, right here, it's x equals, always for your equation of a vertical asymptote. So then, we graph the asymptotes. Somebody said use the dotted line for color. And then finally, you want to make a T-chart with 2 values for x to the right and 2 values for the x to the left of your vertical asymptote. Plot those 4 points and draw your curves. Sometimes you're going to need more than 1 point on each side. Sometimes you need 2. Today, you'll find some places you need 3. Those of you who don't do a really good quality job, you will be penalized. We need you to spend time doing a good job graphing. And the way you do a good job graphing is you have to make a T-chart, plot points. Why do some students not want to do it? They got their T-shirts on. I got things to do. I got texting to do. I'm a tweeter now. I need to tweet. People want to know my thoughts. Everybody good here? Anyone need more time to write this down? Great. Yeah. Let's continue on. So we're going to, like I said, we're going to modify this a little bit. What I want you to do is just kind of, in a pretty quick manner, make the list for this, domain, range, and let's go ahead and graph this back from a parent graph again. All right, let's talk about the list first. What's the parent graph for this one going to be? Y equals 1 over x. It's really the only parent graph we have in the whole chapter. All right. Translation vector. Maddie, what'd you get for that?
I got 1, -2.
That a girl? 1, -2. Remember, take the opposite of what's with the x, and then whatever comes after the function. Okay. Stephen, vertical stretch factor? 2. Taylor, horizontal asymptote. Y equals -2. Corbin, vertical asymptote. X equals 1. Bless you. If we throw those 2 asymptotes on the graph right now, x equals 1, y equals -2, we should be able to identify domain and range. Carlton, how about domain? Remember, these are exclusive. What can't x be?
-2?
No, that was the, what values of these? Look at your equations here. It's easier to look at when you see your equations here for your asymptotes, it tells you what's excluded. So for the domain is x. Shun the 1. Reject the 1. Okay? Or, if you want, you can just say all values of x such that x does not equal 1. Okay? Caitlin, how about the range? Atta girl. So in set builder notation like this, and shun the -2, perfect. So your list is pretty well complete. Hannah, what do I put in for x in my little T-chart here so I can do the graph?
0.
0 would be a good one, and 2 would be a good one. If you plug in a 0 here for x, what would y be? Oh, you know what? Let's not do that. Parent graphs, we don't need that. That's what I've been doing for the last hour and a half. So, parent graph, right one, up one, what do you want to do?
Right 1 up 2.
Right one, up 2.
Right 2 up 1.
Okay, if you wanted, you could go right 2 up 1, and then you have 2 great points, and then just push your asymptote. Oh. But, want to put that up, that's the smart board. The whole thing up. On the left side handle, let's get me a point there. Left 1.
Left 1 down 2.
Down 2, and if you wanted one more for fun, left 2, down 1. And again, we're going to come off that asymptote with something just like this. How about questions on that?
Yes, sir. Yeah, so hyperbolas never touch the graph.
All right, let's go on and take a look at this and say, oh my gosh, this is so confusing. Look at that. Oh, it's got to be so hard. Ooh. Look at rational functions. All I want you to know is that the top of a rational function in these problems are going to be polynomials. In the bottom are going to be polynomials. See this mess right in here? All of this stuff on the top and the bottom, what are they telling you to do with that mess? What is this? All this is telling you to do is what? All the top and bottom of this big, huge fraction, what's it telling you to do? We've been talking about it. What's it telling you?
Go from the biggest power to the constant.
And what do we call that? Begins with D, ends in descending order.
In descending order.
Descending order, that's exactly right. You're good at that game. Right? All I want you to make sure with this mess right here is that we're in descending order. Okay? Now, things that I want you to find on these graphs. I want you to find the x-intercepts. To find them, take the top and set it equal to 0. To find the x-intercepts, take the top, the numerator, and set it equal to 0 and solve for x. There's 2 ways to do that. Do it in your head, write it down. If you write it down, you're probably not going to make the mistakes that first period made. They don't want to do it. I can do it in my head this way, right? Set the top equal to 0. And solve for x. So then you're going to, whatever you get, it'll be that comma 0 will be your x-intercept. So you have some points. The graph of the vertical asymptote, we already know how to find that. How do you find the vertical asymptotes? Set the bottom equal to 0 and solve. The difference now is you may end up with more than one vertical asymptote. And then the third thing, the graph has at most one horizontal asymptote. We talked about that Monday. And the way to figure out what the equation of the horizontal asymptote is, if you go by what I said Monday, cover up everything except the first term, top and bottom, and go with what Paige said and what I said Monday, reduce. That's the easiest way to do that. Now, they have a little chart for you that talks about the degree. The degree of the numerator is m. The degree of the denominator is n. If m, okay, m and is less than n right here, if m is less than n, then the line y equals 0 is your horizontal asymptote, always. And I'll explain that in a different way when we look at our first example. If the numerator degree is smaller than the denominator degree, you're always going to be at y equals 0 for your horizontal asymptote. In 8.2, notice I put the 8.2 right here. 8.2, if the two degrees were equal, then you can just do leading coefficients. But again, I would still do the same thing. Cover up, reduce. It works for both this and this. When m is less than n and m is equal to n, and in fact it works when m is greater than n. But you notice I crossed out m is greater than n. We're not going to do any of those because when you have the numerator degree bigger than the denominator, you get a slant asymptote. And we don't want it. Yes?
Wait, so M and N are the...
Degrees of the top and the bottom. M is the top degree, N is the bottom. I don't use this at all, Robert. When you see me do the examples, I'm going to go with cover up, reduce. It's really easy.
The degree is just the highest exponent of the
Yes?
polynomial, right?
Yep. Yes. The vertical asymptote, the same way you found them yesterday. Set the bottom equal to 0 and solve for x. Now, what I'm telling you is going to be different is you have the potential of multiple vertical asymptotes. Okay? Let's look at an example. Everybody good here? The chart works. It's in your book also. It'll be in your notes posted. It works, but I don't use it. So here's our function, y equals 1 over x squared minus 4. It is not a parent graph. It is not a parent graph. So we go back to what we listed out, the 5 process steps, but we're also going to ask you to find the x-intercepts. We still, of course, want domain and range. I think you are best served waiting for domain and range until the end. If you try to do domain and range before you graph it, it's going to be a real challenge, and it'll be impossible in some situations. So vertical asymptote. Rachel, how do I find the vertical asymptote? Vertical asymptote. Okay, did you take any notes today? But not on today? Okay, how did you find the vertical asymptotes yesterday? Okay, how do we find the vertical asymptote now? Moving on. Who's it? Set the bottom equal to 0. Denominator equals 0. If you write it out, you aren't going to make mistakes. X squared minus 4 equals 0. What does x equal? X equals plus or minus 2. Now, you're welcome to write x equals plus or minus 2. I'm going to write them out. X equals 2 and x equals negative 2. Because I want you to really understand there are two vertical asymptotes. There are two values of x that are out of bounds because they make the denominator equal 0. X equals 2 and x equals negative 2 are both asymptotes vertical. They are out of bounds because they make your denominator equal 0. Now, horizontal asymptote, here's how I do it. Cover up everybody but the first term. top and the first term bottom. So we have 1 over x squared. Whenever you have a number in the top, variable in the bottom, what's your horizontal asymptote? Y equals 0. This is the cookie example. We have a number in the top. It doesn't matter how many cookies there are. In this case, just 1. And we have an infinite number of people in the bottom. How much cookie did you get when we did that? Nothing. So we're going to say y equals 0 is the horizontal asymptote. So we're going to plot that right here. Yes, sir.
Could you explain that more?
Explain what?
How we got the horizontal?
This is how I do it. Okay? Cover up everybody except the first term.
Yeah.
We have a number in the top and a variable in the bottom. There's nothing to reduce, right?
Cool.
Can you reduce 1 over x squared? I couldn't hear you.
I said no because it's not common factor.
Right, there's nothing to reduce. Okay? And in that expression, 1 over x squared, you have a number in the top, variable in the bottom. Whenever that happens, on Monday we said number in the top, variable in the bottom. As you go to infinity, you're approaching 0. You have 1 cookie divided by an infinite number of people squared. You get nothing. Okay? The other way to do it is to use the chart that we have right here, and you say, look, the degree of the top is smaller than the degree in the bottom, therefore it's always y equals 0. There's no mystery here if you're using that chart. The degree of the top, not meant to be a trick question, but for some of you it will be, what is the degree of the polynomial in the top? Zero. There are no x's, so there can't be an x to the first, which would be degree 1. This has to be x to the 0, which we don't write. This is degree 0. What's the degree in the bottom? Degree in the top is smaller than degree in the bottom. It's always y equals 0. Okay? X-intercepts. Again, not meant to be tricky, but the x-intercepts. Spencer, how do I find the x-intercepts? Not for the x-intercepts. Okay? So the x-intercepts of the graph are the real zeros of p of x, which is the top. Set the top equal to 0. So in the example we're looking at, when you set the top equal to 0, what do you get? What is the x-intercept? Okay, let's do it. What does the top say? 1. Set the top equal to 0. What value of x makes this true? Really? None of them. Are you telling me that this is always a true statement? I don't think so. This is never true. Not even on the third Tuesday of an odd month in an even year in a blue moon. Not going to happen. So there are no x-intercepts. And if you look at what I've done for our graph so far, where would the x-intercepts be? Where do x-intercepts have to be? They have to be where? Yeah, you're giving me specifics. X-intercepts are on the x-axis. What else is on the x-axis? The asymptote. Is there any chance we could have any x-intercepts? No way, because that means we were touching the asymptote. And earlier we said touching an asymptote is bad. A no-no. Right? We're spending a long time on this example because it's the first one. And I want to make sure everybody is clear on what we're doing. Notice that we have 2 vertical asymptotes. and it divides your region, your graph, into 3 vertical slices. Some people make 3 different T-charts. That would be me. Others just make one long T-chart. I don't really care. But I'm going to make a T-chart in this region to the left. I'm going to make a T-chart for the region in the middle, in between the asymptotes, and I'm going to make a T-chart to the right. So my first T-chart is going to go right here, and it doesn't matter to me where you put it. I'm just putting it with the region. What should I pick for x in this T-chart? -3 would be a good one, and -4 would be good. For those of you with OCD, you could put -5 and -6 in as well. But let's go to our asymptote. Here we are. It's the x-axis right here. To the left of that, the first integer is, that's why I put that in the T-chart.
You only want to go to the left?
Well, that's all I'm doing because this is the region to the left. I'm going to make another T-chart in here.
Oh, okay.
And I'm going to make a third T-chart over here. So for the region to the left, this is what I'm doing. When you plug in a -3, what's y? When you plug in a -3 for x, what do you get for y? 1/5. When you plug in a -4 for x, 1/12. They're not the prettiest numbers. How would you describe them? Small would be a good word. They're small. So when we graph left 3, we're going to go up 1/5. And left 4, we're going to go up 1/12. All you need to know is that the 1/12 is smaller than the 1/5. So when we graph this, we're going to come along here, we're going to get to the asymptote. Which way do we have to go? Up. If we went down, we would cross the horizontal asymptote. Everybody with me so far? The more of these you do, the better you'll get at them in understanding what to expect. For these types of functions, expect a certain amount of symmetry. Okay, mirror imaging. So I'm going to take you over to skip the middle, and we're going to come over to the region on the right. And we're going to make a T-chart for the region on the right. Anthony, what should I put in the T-chart for this one over in this region? 3 would be good, and just for fun, throw a 4 in there. And you notice that when we plug in the 3 and the 4 into x, what do you get for y? Exactly. We get the same 1/5 and 1/12 because when you square the x's, it takes care of the negatives on the left side and gives you the same result as the positive on the right. So when we look at the graph, at 3 1/5 and 4 1/12, you see that we're kind of mirror imaging. Sorry, missed that point a little bit. We're kind of mirror imaging what happened on the left region. And you can expect that to happen. You shouldn't expect to see on the left the shape in the upper left corner, and then in the right-hand side be in the lower right corner. Okay, I'm not saying it doesn't happen. I'm just saying we don't expect that when we have a squared on the bottom. Now, let's look at the T-chart in the middle. So here's x, here's y. What should I put in the values for x in the middle, Mayros? One would be good. What else? That would be good. And what else? 0. -1, 0, and 1. When you're in between the asymptotes, you should always be plotting 3 points. The middle one, and then 2 others, one left and one right of the middle. Now, that becomes a big problem when your asymptotes are closer together. So the closer together your asymptotes, the less likely you're going to get integers. And the further apart, the more integers you should plug in to make sure you find the general shape. They're not always going to be nice, pretty, symmetric U-shaped like on this graph. Okay? When you plug in -1, what do you end up with for your y value? -1/3. -1/3. When you plug in a 0, -1/4. And when you plug in a 1, back to -1/3. Who's bigger, -1/3 or -1/4? -1/4 is bigger. Okay? -1/4 is bigger than -1/3. So when we graph these points, 0, -1/4 would be here, and -1/3 would be a little bit below the -1/4. I'm not going to get out a ruler and measure, but I want you to see that the -1/4 is higher on the graph than the -1/3. And from the left and right sides come up along the asymptotes. Go back down along the asymptote. The domain is still exclusive. The domain is still exclusive. So when we list our domain here, the domain is all values of x such that x does not equal ±2. Or you can do the shunning stuff and the rejecting stuff, but it's just easier to write it in set builder notation here. The range, however, is not exclusive. The range is not exclusive, so you would have to do two different ranges. You have a range for the top two graphs, which is the same, and you have a range for the bottom graph. What is the range for the top two graphs, the top two sections? How would you describe the range of these two red pieces here? Nope, it is inclusive. I want to know what the range is.
When we did the T-chart for the middle section, I'm not sure why we put the...
They're the integers between the asymptotes.
Oh, okay.
Right? -1, 0, and 1.
Alright. Values of y such that y is greater than 0.
Correct. These graphs, the y values are greater than 0. All the values are greater than 0. We can't get to 0 because 0 is your asymptote. So y is greater than 0 is going to be part of my range. So when we say y is greater than 0, that will be part of the range. And it will be union with the range of the lower section, below the asymptote. What is the range for this little U-shaped deal below the asymptote?
Y is less than 0?
No.
Or all values?
No.
Y is less than -1.
No. You're getting warmer. No. Now you just guessed it. Come on. Pay attention now. Y is less than 1/4. We're close, but not right. No.
Y is less than or equal to 1, -1/4.
Y is less than or equal to -1/4. In this case, right here, it's actually -1/4. So that's got to be included when we list our range values. So all values of y such that y is less than or equal to -1/4, union y is greater than 0. Okay, it's just a little bit different. These are inclusive because on the bottom half, we are not approaching the horizontal asymptote. What's different about this example in the previous example? Christo, do you see anything that's different from this one to the one we just did a minute ago? There is, that's the first one, and that's an inconsequential difference. Do you notice another difference? Did you write down the other one? Or I can go back. Okay, do you see any other difference? Look at this, here's where we were, and here's where we are now. The +2, the other one was a -4, right? The previous problem was a difference of 2 squares. This is a sum of 2 squares. Okay? That changes things. It doesn't change our approach, but it changes how things are going to look. If you take notes, when the bottom is x squared plus a number, and there's only numbers in the top, bottom is x squared plus a number, your graph, better to use them, your graph will always be some sort of a bell shape. Either like that, or like that. Those are called bell-shaped curves. So whenever you have a number on the top and a variable squared plus a number on the bottom, you will get a bell shape. And it's good to be able to know what to expect in your graph before you start. Bless you. On the previous one, when you have x squared minus, and it doesn't have to be a 4, it could have been a 5. Instead of plus or minus 2, we would have plus or minus root 5. You're going to get 3 regions, and you're going to have 2 L shapes that mirror each other in a U shape. That's how this is going to roll in this class. Okay? So, let's look at finding what we know for this one. So let's do asymptotes first. So where are the vertical asymptotes for this graph going to be? Max, what do you think? Vertical asymptotes. How do you find them?
Set the bottom equal to 0.
Okay, so let's try that. Set the bottom equal to 0. So what do we call those? Imaginary. So what does that tell you about the vertical asymptotes? Which means there's no vertical asymptotes. When you set x squared plus 2 equal to 0, because it's a +2, when you try to solve, you get imaginary values for x. That means that there's no vertical asymptote. You don't need to write it down. If you want to write no vertical asymptote, Calvungalas, but it's not necessary. All right? Is everybody following that? Thomas, how about the horizontal asymptote? How do you find it? It's got to be an equation. Do you have notes? No. How's that working for you? Anna?
0.
How do you know?
You guys said degree on the top, so I'm on the bottom.
Degree on the top is 0, degree on the bottom is 2, automatically y equals 0.
I thought you just said when you were looking for vertical asymptotes, I thought you just said the x zero.
The
That
x.
works for me. The x on the bottom,
If you want to find the vertical asymptote, set the entire denominator
so the entire thing.
equal to 0 and solve for x. Did you try that?
Yeah, I don't know, I guess I was a little, never mind. Sorry, I thought we were basically, never mind.
Good.
I got it, yeah.
This has no real solutions,
Yeah.
so there's no vertical asymptotes. Okay? So I usually throw the asymptote on the graph right away because visual is sometimes good. You mean y equals 0? The way Hannah did it, she wrote down in her notes that when the degree of the top is smaller than the degree on the bottom, that automatically y equals 0 is the horizontal asymptote. Okay? The way that I do it is I cover up plus 2, and I do negative 2 over x squared, and I reduce that. Can you reduce negative 2 over x squared? You have a number on the top and a variable on the bottom. What did I tell you that the limit of that was? 0. So y equals 0. Either way works fine for me. But you want to have it written down so that you can study it. And you need to memorize these things. Okay? How about the x-intercepts?
Okay.
Too much thinking.
Wait,
X-intercepts. Robert,
No.
there aren't any. You got a y equals 0 horizontal asymptote. There's no way, no how. How do you find the x-intercepts?
You go,
Set the top equal to 0. What value of x makes negative 2 equal 0?
negative 2. Plus 2.
Okay, listen to this question. Set the top equal to 0. What value of x makes that statement true?
2.
There is no way that negative 2 could ever be equal to 0.
Oh, there's no x.
It's irrelevant. In this statement, we're looking at this statement as it appears. Top equals 0. No way. Can't be a true statement no matter what x is. So there's no x-intercepts.
I have a feeling
What's that?
Nothing.
Okay?
Sorry.
When in the bottom you see x squared plus a number, and the numerator is a number also, it's going to be what shape? Bell shape. This is the way you want to do your T-chart for this graph. Negative 2, negative 1, 0, 1, and 2. You can do more, but those 5 would be the minimum for me. They will always, these bells will always be symmetric around the y-axis for us. Again, whether or not you write this stuff out to figure out what your y's are going to be, that's up to you. Some of you will write them out, you're not going to make any mistakes. Some of you will try your calculators. You might make some mistakes, but it depends on how well you use your calculator.
Why those points?
Because you're always going to be symmetric about the y-axis. So what value of x is on the y-axis? Look at my pen here. What's the value of x? What's the value of x to the left? And to the right? So that's why I'm picking these values. And you will always use those values. If you don't have 5, you will be marked down on this particular graph. This is your T-chart. It's not kind of it. If you want to put negative 3 and and positive 3, negative 4, positive, you can do as many as you want, but those 5 are the minimum. When you plug in negative 2, Jennifer, what would you get for your y value? Girl, negative 1 over 3. Now, since you're talking, Jennifer, what would happen if I plugged in positive 2? You'd get exactly the same thing, negative 1/3, because when you square both negative 2 and positive 2, it does never get the same thing. Sarah, how about negative 1? If I were to plug in a negative 1 here, on the bottom, no, on the bottom you get 3.
Yes.
Atta girl. Negative 2 over 3 would be for negative 1 and for 1. Negative 2 over 3. Bless you. Okay. Spence, how about the 0? If I throw a 0 in for x, what would you get for the y value? Negative 1. Good job. Once you have those points, go ahead and plot them. 0, negative 1 is right here. 1, negative 2/3. Negative 1, negative 2/3. 2, negative 1/3. And negative 2, negative 1/3. You're going to come along the asymptote, bell, and back down along the asymptote. So you get the little bubble when you get to the y-axis, and that's called a bell-type curve, or a bell-shaped curve, or a bubble graph, or however you want to remember.
So these different graphs only have one curve or like one line.
Yes, because there's no vertical asymptote. So the vertical asymptotes will cut you into regions, which give you 2 independent graphs, because they can't cross. In this case, no vertical asymptote, it's just going to be one continuous graph.
Do you get the bell graphs when it's just x squared plus, or does it have to be negative plus?
You need to have a number over x squared plus a number. That will get you your bell. And it has to be plus. You saw with the minus, that's not the case. Okay? Elise, how about the domain for this one? Easier to do it by looking. No, I mean with this.
Oh.
What's the domain? What are your x values?
-2, -1, 0, 1, 2.
Look at my graph.
-1.
Look at my x value. What's my x value? This point right here.
-6.
What's my x value?
-5.5.
Hang, sit where you are. Can you tell me what x can't be?
Less than -.
X, x, x. My x's. Can x be 8? Here's a point right here where x is going to be 8.
Oh, really?
Do you see that, or are you just using your lawyer?
No, I get it.
X can be anything. There's no x's that we don't have. So x is all reals. Who can tell me the range so we can get everybody out of here? So we're going to put y being greater than or equal to -1 and less than 0. For our range. Here is the assignment for tonight. Here's the assignment for tomorrow night. Same section. We have more examples we need to look at to get everybody caught up. So after start